be, but sometime. Okay, so today we are going to talk about unusual points. So our objective is describing how everything changes when you have an influencing point or an outlier. So here's my little graph of the day. You want to tell them to get outlier. Okay. So when graphs have unusual or deviant points, there's three types of deviant points. And this just changed, and it wasn't in your book, and that's why we told you to wait until today. So if you can find your 3.2 notes, which was actually back on page 7, where it said leave blank for now. We're going to fill in those definitions of outlier, high leverage point, and influential point. And in order to figure out exactly what kind of points these are, you have to use your eyeballs and you have to use your calculator. And basically what we're going to do is a lot of calculator manipulations. We're going to take a look at the scatter plot. We're going to identify this point looks suspicious. So let's take him out and see how things change. And that will verify whether or not he's one of these points or she. All right, so this is page 40, but you don't have to turn there. And you don't have to write all of this down. But here is a graph. And we have a couple of points here. This guy and this guy. So on page 7 at the top, let me do this, you have outlier. Basically, to pick out an outlier, you're going to do the following. Number 1, it is a point that is far away from the LSRL. An outlier is a point that is way up above or way down below the least squares regression line, but this is important. When compared to the other points, it has a large, I can't spell large, residual. And we'll draw a picture of that in a minute. So an outlier is a point like this guy right here. See how big that residual is compared to all the other residuals? The next biggest residual is this guy right here. So that's called an outlier. To be honest, I kind of like to call it a residual outlier or regression outlier. I like the term residual outlier because that reminds me that it has a large residual stick, either hanging down below the line or shooting up above the line. That's how you pick out an outlier. Now, what it does to all the statistics, that's coming in where we call it influential. Many times outlier points and leverage points are influential because it changes your statistics. But to be an outlier, you just have to have a large residual compared to the other points. Got it? Okay, so then what about high leverage points? High leverage points are kind of like what we talked about with skew. You know how skew draws the mean towards it if you're doing one of these? Like the mean will get pulled towards the skew. Well, high leverage points are the same thing in 2 dimensions. Because if I were to remove that point, let me remove some of my drawings here. If I were to remove this point, if I were to take it out, how do you think that blue line would change? It would probably go uphill a little bit more. So high leverage points, think of a teeter-totter. And somebody just get off the one end of the teeter-totter, it's going to whoop, right? So that's what a high leverage point is. And this shows you a high leverage point in a regression has a substantially larger or smaller X value. It doesn't have a big residual stick. In fact, usually that line is like attracted like a magnet to it. So that's what we're going to put down for high leverage. So a high leverage point, basically we're going to look to the left or to the right of all the data points. A high leverage point usually has the largest or the smallest X. Value. V-A-L-U-E. So up here, having a large residual means what? Largest or smallest what value? Jeez Louise. I'm having trouble. Y value, right? I saw a really interesting, and it's not really a regression, it's more back in chapter 1 when we did segmented bar graphs. They were trying to decide if you could tell if somebody was a Democrat or a Republican by what they either ate for dinner or bought at the grocery store. Like if you examined all their groceries, could you tell if somebody was a Democrat or a Republican?
I saw like usually pictures of their fridge.
Yes, if you open somebody's refrigerator, could you tell what they were? That I thought was interesting. I bet this time it's like, I don't know, because there's a lot of people switching over. Until about 10 years ago, it was pretty easy for Google, not for Google, for what's the name of the big statistics company that runs all the surveys? I'm so old, I can't think. It was like a big new and coming, you've all heard of them. Gallup. You've heard of Gallup polls? G-A-L-L-U-P?
I have not.
All right. Well, they're notorious for being able to predict elections. But this last election, 4 years ago, everybody got sadly wrong. And that's because more and more people have cell phones, and so you can't call home phones and say, hey, who are you voting for? So how do you get a hold of all people randomly without bias? Which is interesting because that's what we're studying next chapter. And they had a real difficult time with that. So they had to come up with new statistical methods for this one. And so this one, it's going to be interesting because there's so many votes already cast in the election, which I think is kind of the way it should be. Many countries don't just have one day you can vote. They have like 2 weeks you can vote. And that makes it easier for everybody to get there. So we'll see. Okay, so that's a high leverage point. You have to look left and right instead of up and down. And then finally, influential observations. To tell if something's an influential observation, basically you have to take it out of the data set, redo stat test, lim-reg t-test, and see if it changed A or B or R, S, and F, R squared. So a high leverage point, an influential observation. Do you want to see if something's influential? an influential observation when the point is removed from the data set. And then I'm going to put in parentheses, redo stat test WinReg t-test. If A, B, R, R squared, or S change significantly, and that's up for, can't talk and print at the same time. What's significant change? That's kind of up for your opinion. Then the point is influential. So, regression outliers or residual outliers, outliers and high leverage points is kind of a visual thing. You can tell by just looking. Influential observations you have to tell by rerunning the statistics. And that's what we are hopefully going to get good at today. All right, so that fills out page 7 for you. If you could now go back to page 40, I think we'll highlight a few things in here just to reiterate what we just talked about. So if you don't have your highlighter, please go grab it. I found my green highlighter yesterday. I guess it wasn't your class, but I couldn't find it. I put it in my coat. When I got home, I found it. So we're actually highlighting our big packet right now and our page 11 packet. So we're going to highlight both at the same time. That's not page 11. Here's page 11. Is it even here? Nope. Okay. Let me go back to where I want to be. I want to be right there. So this is page 40, and page 11 has, I think, the same thing exactly. Yes. So I would like you to highlight for outlier has a large residual when it's calculated. And you want to highlight the same thing on page 11 where it says outliers. Has a large residual. For high leverage point, we're going to highlight substantially larger or smaller X values than the other observations have. So that's what you want to highlight on page 40 of the big packet. And you have to go down a bit and highlight there usually the leftmost or rightmost point. Oh, you can also highlight substantially larger or smaller X values than the other observations have. And then the last thing we're going to highlight, influential. If removed, it changes the relationship substantially. And that means you're looking at all the statistics. So you can highlight that on page 40. And you can highlight the first sentence. If removed, changes the relationship substantially. So you guys at home, this is what my little packet looks like. Just a few little things highlighted. That's at the bottom of page 11. And then you can see on the board that I'm sharing with you, the screen that I'm sharing with you, what we changed on page 40. And I guess it wouldn't hurt if we go out here and say, This guy right here, it says outlier because that is a big residual. And they don't call it this on our picture. It says this is not an outlier. But this point up here, is a high leverage because it's the last point. See how much space there is between this guy right here and this guy? So this has the largest X. And that's what makes it a high leverage. All right, here's what you have to understand. Not every data set has these points. But it's going to feel like that because we're learning, and most of the data sets we're going to take a look at have something for us to examine. But not all data sets have these points. All right, we ready to go to page 41? You guys at home okay with us so far? Okay, so here's page 41. See this data set right here? If you were drawing an ellipse around there, it's pretty circular, right? All those points are pretty clustered together, and it's really a weak relationship. And you can see that because the R is only at 0.41, and look at the R squared, it's at 0.17. 17% of how the Y's go back and forth are explained by how the X's go back and forth. This right now has no unusual points, and it is a weak relationship or a weak association. This is a weak association. That's case one. Now look immediately to your right. Here's case two. We've just added this point. We've added that point. Now look how the ellipse has changed. Look at how that ellipse has changed. It really looks pretty skinny now. We just went from 0.17 up to 0.89. Did the equation of the line change at all? The equation of the line did not change at all. But boy, there's a lot of space between the last X over here and that X. So what kind of point would we call this visually? You have a choice. It's either outlier or high leverage. This is a high leverage point. I don't think it says that on your graph. No. Up in that gray square, you can add that that's a high leverage point. Now, I will tell you that usually high leverage points change the equation. This one didn't. This one did not change the equation, but it did change what? R squared, and S. It made S a little bit better, right? Not too much better, but a little bit. So not only is it high leverage, it is also influential. IAL. It's influential because it changed those. It changed the R's. Yes?
What did the R's show?
Well, the single R shows how nicely the little dots are in a straight line. The single R is why we draw the ellipses. Okay? The R squared, you missed the video yesterday. You'll have to go back and watch the AP Stat Guy's video, because I was about to say, were you asleep during the video? And he's like, oh, no, she was not feeling well. So the R squared tells us how useful the X's are at predicting the Y's. So right here, before that point was in, the X's didn't help us out very much. This is like a 17% sale. Would you go to some place that had a 17% off? But if they said, hey, everything's 89% off, you'd be at Kohl's in a second because you're giving stuff away almost. So that's what R squared does for us. And if you watch the AP Stack Guy video, it's only 10 minutes and it's linked to yesterday's stuff. I'll show you. That's what it does. But I don't know. Don't you guys think that the AP Stack Guy video like really solidified that for you yesterday? Like he did that drawing of the rectangle in. All right. Okay, now let's go to case 3. So take out this point. Pretend we're back here. Very weak association. And now here's case 3. Does that dot have a big residual? Does it have a large residual stick? No. But look how it changed from a positive slope, it changed it to a negative slope. And look how skinny my ellipse is. This is usually what a leverage point does. And I just told you this is also a high leverage point. It's high leverage because look at the space right here. Look at the x-axis space between this x point and that x point. These x's end at 6. That one's over at 35, comma something. So this is a high leverage point also. Is it influential? Did it change any of our statistics? Well, it didn't really change this too much, did it? It didn't really change the 18. Oh, I have this on backwards. Hang on just a second. But it did change my R, right? Changed my R from positive to negative. And it changed my S a little bit. So this is also influential. It's influential because it changed R and it changed A and B. So I'm going to put that up here. It changed R, A, and B the most. It's a rad point. I just made that up. It doesn't mean anything. Hang on just a second and I'll get Maria's question. If we go back to here, let's go back to case 2. Case 2 didn't change A and B, but it changed R and R squared and S a little bit. So it's influential because it changed R, R squared, and S. So influential points, as long as they change one of those 5 things, it's influential. Okay, Maria's question.
So for the third one, why did the R value get closer to 1? Because isn't the relationship stronger if the ellipse is skinnier?
Yes, but I think the reason it didn't make R stronger is because when it tilted this, it made some of these residuals back here bigger. So Maria's question is, why didn't the R's get stronger like it did here? Here the R's got a lot stronger. So if we draw these residual sticks in here, that one hardly has any residual stick, right? And now if we go here, those didn't change too much, did they? This is what I'm going to say. I haven't verified that their statistics on this are 100% correct. I guess I should do that as a teacher. Maybe they're lying to us and maybe the R's really did change. I'll have to investigate. Because you would think that that would make it stronger. So I don't know. It's a very good question, and I will investigate that. And if you remember to ask me about it, I'll tell you if this example's lying to us. Maria's question. That will be enough to remind me. That's a good question. I think the R's should have changed a lot too, but maybe they just wanted to make the point that this became negative. Yes. How about after one more case? All right, so now here's case 4. You see how this guy, if you look to the left and to the right, he's not really very far away left and right compared to the other points, agreed? But boy, does he have a what? Really big residual. He's adding a lot of error. Remember, residuals are the unexplained errors. Residuals are the things that we can't explain, and boy, did he add a whole bunch of what we can't explain. So here's our old statistics. Look at how much worse things are. R-S-W-O-R-S-E. I'm really having a spelling day. And I went to sleep early. These all got worse. And the slope didn't change at all, but boy, the y-intercept changed. So not only is this an outlier, which I would call regression or residual outlier, because that's what I called it for 18 years until they changed the curriculum last year. But it's also a what? Influential observation, because it changes A, R, R squared, and S. S really got bad. We used to only be 2.77 units of error, and now we're 10.82 units of error. This one stinks. All right, Liz, go ahead. Okay, so we're going to fill out 42 real quick. And then we're going to actually do one of these in our calculator. And then we're going to try to do the animal thing the whole way through. And then we'll be done. And then Monday is, after I show you how to do the conclusion, we will be finished with knowing what to do with all this stuff. And next week, Tuesday, Wednesday, Thursday is all review. Tuesday is the group review known as the team test. You guys at home, any questions with what we're doing here yet? You're good? Okay. Alex, question? It can be A, I think I heard you. So if I didn't hear you right, you can say it again. But this is what I think it is, Alex. To be influential, you just have to change one of A, B, R, R squared, or S. If you change A, it might change B and it might not. If you change B, it might change A and it might not. Influential, it doesn't matter. It just has to change at least one of the five. One or more of the five. Did that answer your question?
Did it always happen and have an outlier with it, or high level?
I'm not sure I heard you, but a data set doesn't have to have any of these unusual points. And if it does have an unusual point, usually points are not outliers and influential observations. Usually that does not happen. But occasionally it does. Usually it's either an outlier or it's a high leverage point. Most, I'm going to say 99% of the time, if a point is an outlier or if a point is a high leverage point, then it, yes, will also be influential. But in order to be sure about that, you have to take a look at the new statistics. Did that finally get your answer? Okay, very good. And you can always type in the chat too, because sometimes your audio is hard to hear. So if I didn't really answer your question, you can type it up and send it as a chat and I'll see it. Okay? All right, ready? This is just talking about the cases, and we already have that on your thing, so here we go. And this reminded me of lions and tigers and bears, oh my. Outliers, influential, and high leverage, oh my. That's why I put oh my there, just in case you want to know. Okay, so you guys might want to use different colors if you have them. What does an outlier look like? So let's do it this way. Let's put some points like that. Draw a line through those. And then if I put an outlier down here, I'm going to call it outlier. What will actually happen to that line is it will actually drop a bit. It usually doesn't change the slope. So the first thing I have is location. LOCATL. Okay. So the location is up and down. Large or small y. Value. Compared to the rest. So, kind of to answer Alex's question, just because a point has the biggest y value does not make it automatically an outlier. Like if I take that red point away, then there are no outliers. Okay. Down below. What does it do if you took out that red point? Or if you put the red point in? But this is when you remove the special points and recalculate. So, if it is an outlier, an influential observation that is an outlier, is it going to change my intercept? Yes. This will change. And that will either get what? Depending upon if it's an outlier below, or if it's an outlier above, then that blue line would just slide up. So A is going to change. It will either, if it's a positive residual, A will increase. And if it's a negative residual, A will decrease. Is my slope going to change? Not very much. So the slope, I'm just going to put a question mark by. Usually the slope does not change much. Not much change. Okay. And this isn't cast in stone 100% of the time. This is just a guide for you. If I went up here and I took that red point out, is R going to change? Trent says yes. Yes, this will probably change. And how is R going to change? It's going to get stronger, which means it's going to get either closer to 1 or closer to negative 1. I can't say it increases. R is going to get stronger. So it's either going to move towards positive 1 or it will move towards negative 1. Now, R squared, since we're squaring it, it's always going to increase and get closer to positive 1, because that's what makes it stronger, since it has no plus or minus sign, really. It's always positive. That's going to change. It's going to get stronger, and it will always move towards positive 1. And S is going to get better, which means we have less air. So what's S going to do to get better? Decrease. So this is usually going to change. This is going to decrease. And decreasing is a good thing for us because that means better. Because that means less air. Does that make sense? So there's a lot to remember here, and if you're a memorizer, then that's a bad thing. Try to be an understander and not a pattern memorizer. Any questions before we go to high leverage points? You guys at home okay? I see Zach okay. Jenna, I think I see you. Yeah, okay. You're good, Alex? All right. High leverage points. Let's put some points in. Let me go like this. And this will be the LSRL. This is the before line. And now let me put a high leverage point in. I could put a high leverage point in like over here. I'm gonna call it HL. If I put that line in, can your brain see how the black line's gonna change? Can it imagine what's gonna happen? This line is gonna go from, give me a second. All right, hang on. I'm gonna change that to red. Come on. There we go. So what's gonna happen to this line? Can you guys tell? That point's going to attract it, so it's going to lose its slope, but its intercept is going to do what? Increase. And I'm going to make this more like this, because otherwise it's a residual point too. I mean, it's an outlier. We used to call them x-axis outliers. That's why that says that. But for me, for right now, just scribble out that word, because I don't want you to think outlier here, because they don't use that language for this anymore. Okay, so location. Location of a high leverage point. You're going to look left or right. Can a data set have high leverage points and outliers, both up and down outliers and left and right high leverage? Yes. And then what happens? I don't know. You gotta go in and do the data. You gotta go in and do the stat test to figure out what will exactly happen. Okay, look left or right. Okay, I've frozen. I don't like that. Please. There we go. Okay, so it has a big or small x value when compared to other points. Okay, so is it going to change A? So this is high leverage. It's going to change A somehow. It's either going to increase it usually or decrease it. It doesn't have to do that. In fact, case 2 that we looked at on page 41 didn't do that. B, it's going to change B. It's either going to increase it or it's going to decrease it. It all depends. Is it going to change R, R squared, and S? Maybe, maybe not. Probably. And if you take that point out, if I were to take that high leverage point out, I'm just going to say these probably change, but you have to explore it to see how it changes. Usually when you take high leverage points out, many times those things get worse. So usually these get worse. Okay, I think we have enough time to do this. So we're going to put our page 43, we're going to put the points in the calculator right now. And I know this is a long day, but we got to get this in for a variety of reasons. Okay, here we go. I want you guys to remember how to put points into the calculator. So the first thing I'm going to do is I'm going to clear out my screen. So hit clear, and then hit Y equals and hit clear. And any plots you have turned on, go up above there and hit enter so they're all off. And you do not have to do this tonight for your homework because all of these points that you need are already in your calculator, but let's hit stat, edit. You want to find list 1 and list 2, and if you can't find those, I can help you do that very quickly. You want to clear them all out, and you want to add in the points that are on 43. So X is going to be 1, 2, 3, 4, 10, 10. That's what X is going to be, and I'll come around and help you guys in the classroom, and I'll help you at home also. And then Y is going to be 1, 3, 3, 5, 1, 11. 1, 3, 3, 5, 11. And you can do second Y equals stat plot zoom 9.
It's 5, 1, 11.
5, 1, 11.
Yeah.
1, 3, 3, 5, 1, 11. Thank you. Anybody here need help? How about you guys at home? Are you okay with that? Or do you need help finding something? Okay, we're good. Let's hit second Y equals. Go to plot 1, turn it on. Come down here and put, you can just do second 1 to put L1 in there. And then down in longevity, you can do second 2. And then go up above and hit zoom 9. And I want you to put that very quickly, sketch that on your paper. Make it kind of tiny. And then I'm going to put A, B, R, R squared, and S next. Okay, we ready? What's the next thing I do with the data set? Stat, test, up to Linreg t-test, put in second 1 and second 2. Make sure you have a Y1 in there and hit calculate. And I'm going to put all of this information down that's right here. A, B, S, R squared, and R. So A is 1.75. B equals 0.45. S is 3.67. R squared is 0.23, and R is 0.48. And I can just bring these over here, Mrs. Garrett, just so people at home can see. And we're not going to fancy it up. We're not going to put the, because there's no context here. This is just so you can see what's going on and what we're gonna try to do. Okay. So my R was 0.48 and my R squared was 0.23. So that is the original stats. And if you hit Y equals right now, or if you hit graph right now, you can see how that line comes through. It splits the difference between the last 2 points and it goes right through my third point. So when I come here, I'm gonna say, okay, this original line goes right here, and it splits the difference. So this is my original, and I'm gonna call it ORIG. All right, this is my hope, and I think I know what some of you can do. The point 10, comma 1 is which point on this graph? The point 10, comma 1 is this guy right here. If I take him out, do you know what's going to happen? I guess I should have put this all under the width. This is all under the width. First off, can you tell me, is it an unusual point? Yes. Would you call it an outlier or a high leverage point? It might actually kind of be both, right? Although it's not the furthest x, because this is 11. So what kind of point do you think that is? Probably an outlier. So I'm going to put over here without that point. I think that point is an outlier, right? Good morning. I think you should, I don't know, I think you should definitely turn this on though.
Okay.
All right. Okay, so let's take a guess at what's going to happen when I take this point out. So over here somewhere put A, B, R squared, and S. And can somebody tell me what they think is going to happen when I take this guy out of there? What's going to happen to the line? It's going to go what? Which means its slope is going to do what? Increase. So this is what my gut instincts tell me. And if you don't have these gut instincts yet, that's why we're doing this. So we think this is going to increase. What's going to happen to the intercept? It's going to decrease. What do you think is going to happen to the R? It was 0.48. It's going to get closer to 1. What do you think is going to happen to the R squared? It's going to get closer to 1. And what do you think is going to happen to the S? It's going to decrease. It's going to get better. Decreasing S is better. Sometimes decreasing R is better if it's negative. So we're going to go take that point out now and redraw all this stuff. So this should be on the without side. So right now we're checking to see if it's influential. We already said it's an outlier. Okay? So how do we do that? Ready? I am going to go into Stat, Edit. I'm going to go down and take the point out. Delete. Over here, delete. I'm not hitting zoom 9. You have to try to force yourself not to do that because that's my gut instinct. I'm now going to rerun Stat, Test, WinRig T test, but be very careful because guess what I'm going to change Y1 to? I'm going to change it to Y2 so both lines show up. How do I do that? Alpha trace. Hit the green alpha button and trace is the very top, second one in from the right. Choose Y2. Hit enter. Go down and hit calculate. Everybody get that? Anybody at home need to see that again?
Where's Trace?
Trace is the second one on the right.
Like that.
Way at the top. Hit calculate. All right, let's copy these things down. See if our instincts were correct. There's some of my new statistics. You guys don't have to copy them down. I'm just doing this for anybody that's missed, because this will be a sad day to miss. Okay, so let's see. What did A do? A used to be 1.75. It's now 0.28. So I want you to play secretary. This is now 0.28. It did decrease. Hip hooray, we were right. B used to be 0.75. It is now 1.08. It did increase. Yay, yay. S used to be 3.76. S is now 0.54. Did it get better? Yeah, it got stronger. It did, in fact, go down. R used to be 0.48. It's now 0.99. Did that get better? It got way better. And R squared also got way better. It's I'm gonna put 3 decimals this time. It's 0.985, and it got way better. Last thing to do is to draw a new line in a new color without that green dot. And my guess is it's going to go up something like this now. You don't have to draw that in yet. Let's just see if we're right. And then I'll answer Ella's question. So in order to do that, just hit graph. If you hit zoom 9, it will be off kilter. It will be off. That's the old one. Here comes the new one. Look at that. It goes right through the first and last dot. So I was off, actually. I didn't do it as best as I could have. That's the new one. And I want that graph. That's what we're going to put in. So this was the new. And this was the old. Yes. Ella? Yes. And then I'll tell you guys what your homework is. And it will be, okay. So first, Ella, let me go put it back in here. Okay, this was 10. And then over here, this is actually 1 and 11. So first thing I have to do is go back to this screen and hit delete here and delete the 10 that goes with it. Stat, enter, because it's already an edit. Okay? And now just do stat test, linreg t-test of L1 and L2. But right now yours says Y1, right? So you want to be blinking on the Y1 and hit alpha trace and go down to Y2. And then go down to calculate, and you got all your new stats. And if you hit graph, you can see the first line come in. That dot's missing, so that's why we wanted to put the first graph down. Okay? So that's all the new stuff. I don't know how well some of us will do at this. Your homework is to do the following. Your homework is to do page 44, and I think you can get through 45. You should be able to do 44 and 45 with the young drivers. And the data, is it in your car? I don't think the data's in your, the data's not in your calculator. So let's put the data in. So you can just put it right into L1 and L2 if you want. It's 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and is it 26? Nope. And L2, I'm going to clear it out. L2 is 23, 20, 19, 15. $17, 14, 14. 17, 11, 10. And if you want to ever check the data you enter into your calculator, like you'll have to on your team, not on your team test, but on your individual test, ready? You're going to do stat, calculate, 2 variable statistics. I'm going to put L1 in and L2 in. And come down to hit calculate. And now look, does X bar equal 20.5? See how it's on your paper to check it? And then you can go down to Y bar, is Y bar 16? Yes. So I want you to get as far as you can in this packet. If you can get all the way down to 46, yay you. I'm actually going to try to do a video on this and put it out there to show you the whole way through it, in case you need help. Okay, but your homework this weekend is definitely get page 44 and 45 done. And if you have time to do page 46 and you need help following along with the video, then do that too, please. All right? Is everything okay?
Yeah, it was about some pumpkin I brought in school.
Oh,
But it's fine.
funny pumpkin?
It was just the regular one.
Okay, you guys at home okay with that?
Wait, is it on the sheet? Because I didn't put it in either.
Yeah, it's on page 44, it's on the sheet. The date is on page 44 if you need it. Okay, and Alex, I'm gonna do a homework video. Yes, you can have an influential point by itself. What else does it say? What else? Here, let me see what else did you chat? How can I get to that? Oh, I got it. Oops, I don't have a touch screen here. You guys, Zach and Jenny, you can go unless you have questions. Okay, if you ever have an influential point by itself, the examples have always been outlier and influential. No, you probably will never have, I don't know, I guess, Alex, the answer is it could happen, but I can tell you for what we're going to be getting in this class, it won't be. If it's influential, it's either going to be outlier or high leverage and influential. But yeah, I suppose you could have an influential point. It could be all combinations, but the only way to tell if it's influential, Alex, is to actually take counts.
Yeah. Oh, I haven't
Have a great Halloween weekend.
Oh, sorry, we're all friends. So, I forgot my afternoon class.
All right, I didn't hear that, but hey, if you make any Halloween cookies, let me know. All right, have a good Halloween weekend. Bye-bye.
Yeah. It's.
Step on you and destroy your life little by
Oh,
little.
you said you studied.
I did last month. I have it like glued to my head. Don't do that.
Okay, just so you guys can relax a bit, we're not having that quiz today. We have